What is the idea behind it? Why are these companies or tools so successful? For example, why is Google the search engine we use on a daily basis? Do you still use Yahoo or Bing? Or do you even know them? How do language assistants know when to listen to you? What they need to improve in order to meet your needs? What kind of updates are needed? Why do dating services suggest a certain profile for you? How do they know where you are and who would maybe be the perfect fit for you? How does your GPS work? How does it know the shortest path in every city, wherever you want? Or why do we use no GPS anymore but Google Maps? How do web shops know what articles we want to buy next? And what about all the other apps on your phone that help you to organize your daily routines or allow you to use social media? What makes them successful? Or rather, why do they know us that well to precisely present us with answers, advertisement, and suggestions that suits our needs? Isn't that a little bit scary? How does this all work? I will tell you the answer with the help of secure and well-written algorithms or programmers who write them and ask themselves exactly these questions. Okay, but what is an algorithm? One definition is a formal description of a solution for a class of problems. A class of problems are problems that have something in common. Another definition is an algorithm is a finite sequence of instructions that take a possible empty set of values as an input and produces a set of values as an output. So we try to find a procedure to solve our problem, and we want to know the best way to describe it. Of course, there can be several possible solutions for the same problem, and certain requirements have to be considered. The result of this procedure is called an algorithm. It clearly determines when and what is to be done, so it defines the sequence. The individual actions can be executed sequentially, one after the other, but also in parallel. You can think about it in this way. Programming means telling a computer what to do. Do this, then do that, then take the two results, add them up this way and repeat until you get spaghetti. Yes, that's right. It's not just that programming is as easy as cooking, but a recipe is an algorithm as well. In daily life, we encounter instructions of various kinds. Other examples would be building instructions, musical notes, rules of a game, or the conversion of binary numbers to decimal numbers. Programs are only the implementation of these algorithms in a special programming language. Now let's discuss which conditions an algorithm has to fulfill. A game manual says, "The bravest player begins." Such instructions are useless for a computer, since it is not explicitly defined how the bravest can be found. A well-defined algorithm should also be universal, meaning it should be able to solve several problems of the same kind. For example, if I want to know the fastest way from Graz University of Technology to Graz University by bike, it should give me, of course, the exact answers, but it should also be applicable to other routes. To write a completely new program for this would be nonsense. That's why places I want to go, or their coordinates, are only the input data or parameters for my program. The algorithm behind it should deliver a result for every place in Graz or even all over the world. It should always tell me the fastest way from A to B. A further characteristic of an algorithm is finiteness. It means that an algorithm has a finite length, which means a limited number of instructions. This is a static finiteness. And it has a finite amount of space for storage. Therefore, only a finite number of resources can be occupied. This is the dynamic finiteness. Three more important characteristics are: first, the termination. This means that the algorithm must stop after a finite number of processing steps and should deliver a result. The algorithm should stop regardless of the given input. Otherwise, we would have the holding problem, as discussed in short in Module 1. Second, determinism. At any time, the next step is exactly defined. There is only one way. Third, determinacy. If the algorithm always returns the same output for the same input, it is called deterministic. This does not apply if randomized processing rules exist and the result is random. If an algorithm is deterministic and determined, it is defined in every step. What to do, that are the operations. What should be done, that are the operands. How to proceed, the next steps. Deterministic algorithms are always determined, but not the other way around. To sum up, this video showed you why it is necessary to consider important characteristics of algorithms. In the next video, we will learn about important constructs and start to build our first own algorithm in the form of a pseudocode.